Alright guys, welcome to this page of the notes, and I got a couple more problems here for us to go ahead and try by simplifying the rational expression and then figure out under what conditions it is undefined or how we need to restrict our domain values. So here we go, let's just jump right into this one. Again, I take a look at this and it looks like I got a little bit of factoring to do in the top. I recognize the 4w squared and the minus 3wy. Well, I can pull out a GCF of w. So let's do that. I pull a w out of this quantity, and that's going to leave me with a 4w minus 3y. That's all going to be multiplied by w plus y. There's nothing I can do to that guy. In the bottom, there's no GCF here, no other GCF I can pull out, also no GCF there, so I'm just going to leave them the way that they are. But that means that I don't have anything that cancels yet. And here's where these are a little trick. The reason I'm giving you this example problem is a little trick that you're going to want to watch out for. Here's what I recognize. Right now, nothing goes away, but I'm really close on something. Please notice it's a positive 4w and a negative 3y. And in the denominator, I have the opposite, a positive 3y and a minus 4w, right? The signs are just different. So if I can get those signs to switch, then those quantities will cancel top and bottom. And the easiest way to get the signs to switch is to factor out a negative 1. So in the top, it turns out that my GCF was not just a w, but in fact a negative w. If I pull out a minus sign, this will become a positive 3y, like I have down here. This will become a negative 4w, like I have down here, and those factors will cancel. So let's do that. Let's factor out that negative 1. Gives me a negative, right? I pull out a negative 1 that gives me the negative w. And then those guys will switch signs. The 3y will become positive. The 4w will become negative. And then I have the w plus y. And in the bottom, I'll have the 3y minus 4w and the 5y plus w. Those guys cancel top and bottom because I pulled out the negative, and so I get those guys to cancel. And so my reduced form is simply this. Looks like negative w times w plus y all over 5w plus y. Now, another reason that I gave you this one is we need to take a look at the restrictions. In all of the example problems we've done so far, it has all been in a single variable. They've all been x's, they've all been y's, they've all been z's. But in this one, I actually have two variables. We have w and y. So what I want to show you is there actually is an infinite number of restrictions. I will only show you a couple of them, but there's an infinite number of restrictions, and here's how I know. I cannot let the denominator, I don't want the denominator to be 0, right? Can't be 0. So I set 5w plus y equal to 0, which means 5w is equal to a negative y. Now, let me give you a couple of examples. Couple of examples. Well, here they are. What if w was a 2 and y was a negative 10? Well, if w is equal to a negative 2 and y is equal to 10, right? Negative 2 times 5 is a minus 10. 10 times a negative 1 is a minus 10. Again, minus 10 equals minus 10, right? And so negative 2 and positive 10 are restricted values. Let me give you another one. If w is equal to 5 and y is equal to 25, right? If I plug in a, sorry. I want a minus 5. Minus 5, that'll get me the same. Minus 5. If I plug in a negative 5, 5 times a negative 5 is a minus 25. 25 times a negative 1 is a minus 25. And so another restricted value would be if I plug in a negative 5 and a positive 25, right? Those will cancel each other out, leaving with 0 in the denominator, and that's not okay. One more just to show you that there's an infinite number of these. You could go through and just keep finding ones and finding ones and finding ones. Infinite number of them. If w were equal to 3 and y were equal to 15. 5 times 3 is 15. I'm sorry, it needs to be, I did it again. It needs to be a minus 3. If I plug in a minus 3, 5 times a minus 3 is minus 15. 15 times a negative 1, minus 15. So there you go. There's just 3 examples of a w and a y value that'll give you 0 in the denominator. It turns out there's an infinite number of them. You can find a ton of them. So just be real careful. If I ever give you one where there's multiple values, I actually, when I ask you for the restricted domains, I won't ask you, obviously you can't list all of them. There's an infinite number of them. You'll just put infinite restrictions or the domain is limited infinitely, that kind of thing. All right, let's do another one that's much more like the ones we've been doing. B's, right? All I have are B's in the denominator. So here we go. We take a look at this one, and it looks like in the top I have a GCF, right? I can factor out an A and a B. So I'll do that. I pull out an A and a B. That's going to leave me with a B minus 5. Okay, now in the bottom, it's already factored for me, 5 plus B and 5 minus B. Well, I'm again really close, just like we saw up above, right? Here the B is positive and the 5 is negative. But this one is the opposite. The 5 is positive, the B is negative. So if I pull out a minus sign, minus AB, that's going to leave me with 5 minus B, right? You switch the signs. Pull out a negative, the B becomes negative. Pull out a negative, the 5 becomes positive. And now that'll cancel with the 5 minus B in the bottom. So just watch out for those where you may need to pull out an additional minus sign in order to get a GCF top and bottom that will eliminate. That leaves you with negative AB over 5 plus B. Do your restrictions. I need 5 plus B to be equal to 0, which means, B, not 5, B is equal to a minus 5, where B cannot equal minus 5. There is no restriction on the value of A because A only appears in the numerator. So even if A were 0, no problem. Zeros are allowed in the numerator. You just can't have 0 in the denominator. Guys, head on over to the next page of the notes. I got a couple more of these for us to work through. I'll meet you over there.